including GDP.
One second, Krishi, whenever like you have start all your notebooks with the data source links and references.
Oh,
Okay.
okay, okay.
So in notebooks, you have code and markdown blocks, right? Always add a markdown block where you tell some context about like what is the exercise, what we're trying to achieve, what are the data sources.
Okay,
Yeah. Make a note of these things so that you can get back to them later.
sure. Yeah, we have we are importing the downloaded GDP data into a pandas data frame here, and this data frame here, and filtering out only for these 5 countries, since we have chosen those countries for our analysis.
And the reason that we went with these specific countries, India, because we are interested in India, United States, which is like the aspirational country, and Germany, we wanted to pick one country from Europe. China, because China and India are like comparable in population and their neighbors. And we picked Bangladesh because this is like one of the developing country and which made lot of progress recently. So instead of looking at all countries, we wanted to look at the data for these 5 countries, which will give us like some insights. Go ahead.
Oh, uh, once we filtered out GDP data for those countries, we are plotting the GDP trends of those countries, which is shown here in this image. Here, the data for Germany is missing from the time period 1960 to 70. Uh, we have taken care of that somehow. We'll talk about that in a bit. Yeah, here it is. For the 1960 to 70, the GDP data for Germany is unavailable. So we have decided,
Missing data and NAN value.
yeah, handling NaN values here by finding the median of the entire row for Germany. Then we are plotting the adjusted value for Germany, but here there is an inconsistency because it was for median, but ideally it would be uh, it must be used any linear regression algorithms, machine learning algorithms, something. Uh, for population data, we have downloaded a source from the World Bank data and loaded it in the pandas data frame. Here we are filtering for the same countries, just so we could find the GDP per capita later. Uh, Here we are plotting the population for those countries. Here we have loaded the GDP GDP data frame and filtered out those countries which we were already discussing about. And yeah, and imported the population CSV file for to calculate the GDP per capita, which is GDP divided by the population for each year for every countries. We are selecting the same countries for plotting and calculating the GDP here. Here we are calculating it by dividing India GDP by population for each country for each year. Here we are adding the GDP per capita into a new data frame for the above mentioned countries. Then adding the here the country name was missing, so we we are adding the country name as a separate column here, inserting it in the first position. Then we have plotted using matplotlib for the countries.
So as you can see from the graph, right? So anything that we will be plotting in future, we will be using ratios as much as possible. We will be using two types of denominators. Numerator will be the metric that we're looking at. Denominator will either be population or the area of the land for which we are calculating. And if you look at the GDP plot that we did before and now, it is pretty clear that United States and Germany are way ahead of the other three countries that we're looking at, India, China, and Bangladesh. And you could also see that like India and Bangladesh somewhere closer, but China is way ahead of both these countries. So this shows you like when you use per capita, you get like more realistic data. When you're looking at trends, growth, and comparing different entities. Whenever you're looking at the actual demand or supply kind of it where you want volumes, only in those areas we will be looking at volumes as in absolute values. In all other places, we will majorly try to look at ratios. Over to you, Krishi.
Uh, then we are calculating the GSDP data, which is GDP for every state of India. We have downloaded the data from government official website for which the link is mentioned there. We have loaded the GSDP data set into a pandas data frame here, and handling all the zeros here by finding the mean for each row, making sure there is no empty values, then plotting the
Krishi,
GSDP.
one thing is instead of looking at means, no, I think we should generally look at linear regression as the easiest, what do you say, best approach for backfilling the data.
O-
So take that as like one activity. Let us do that somewhere. Okay.
Okay. Then we are plotting here using the matplotlib library. We are plotting the GSDP of Indian states. Uh, since the space is not enough for all the states, which is about 30, so we have segregated the states into zones like east, west, north, south, and northeast. We are segregating the states here and adding it to a new data frame for each zones, and plotting those zones separately in using matplotlib library. Plotting each zone wherein each states consists only of east states we have added earlier. This is for the east state, west states, north states, and south states, and then finally northeastern.
Krishi, did we do for the per capita? These are all absolute numbers, right?
Yes, sir.
Or per capita, right? Okay. So one thing that we can observe here in the Northeast is Assam seems to be like way ahead of like other states. Uh, we should see whether it is because of higher population or is it like in absolute terms also they have growth. When we're looking at per capita, let us concentrate on the Northeast once again. Okay. Yeah. Carry on, Krishi.
Oh, then we have loaded in this population data from Living Atlas website, for which we only had 2011 data, but we have GSDP data since 2004 to 2023. But we only the 2011 data is available. Here 2014 to 15 cut here.
Yeah, that is because generally like census happen in 2001, 2011 and so on, every 10-year gap. So the last census happened in 2011 and in 2021 census didn't happen. It might happen by the end of 2024, I guess. So generally any data set that we're looking at, we should look at it like spatio-temporal. So we should always know the data is for like which particular year. And whenever we are trying to convert that into a ratio, we should always look at the denominator is also for the same time frame or the same geography, and in case if it is not there, we will try to do simple projections. So the easiest way of doing the population projection for states would be look at what is the population in 2011 and current population we have like 1.4 billion, so try to look at like what is the ratio between those two things. If you have the latest year, we go by that. If not, from 2011 to 2000 current year 24, we just draw like a linear curve and then we get the values for each year and we will store that, and then we will use it for the ratios in the denominator. Okay. Okay, go ahead, Krishna.
Uh, Here we are creating a new data frame with just the columns we needed, since there are too many columns in the raw data we collected from the internet. So we have added the state column here in our new population data frame, and then adding the states for population from 2015 to 22, since that is only that is relevant for our analysis here, and exporting it into a CSV for the calculations of GSDP per capita. Here Here we are predicting population for the year 2004 to 14. Since we only have data from the year 2011, it is essential to predict the population for calculating GSDP per capita. So here we are taking in the uh, population that we just predicted in the previous file. So taking in only for the Andaman state here, sorry, Union Territory. Selecting the first row and converting it into a column for analysis. We have plotted a
What was the
basic
state
plot.
that you considered here?
Andaman, sir.
Andaman. Okay.
We have plotted a sample plot for basic idea and predicted the next column using the linear regression model here from the scikit-learn library. Here we are predicting the data for the Andaman with the population data from 2015 to 2023. With those data, we are predicting the population for 2004 to 2014 here, and adding it into a new data frame. Uh, Doing it just for one state here, just to get the grip of the process. Uh, After that, we started to predict population for all the states for following the above process, but for all the states now from the year 2004 to 2014. Here we are using the same approach by converting it into a vertical column and predicting the population for the year 2004 to 14 and converting it into a new data frame here named as final DF. Here we have all the states and union territories name in order, and we have opened the predicted column population here and exported it into a CSV for further calculating the GSDP per capita.
So, Krishi, one thing that we need to do is wherever we use the prediction models, no, so we should always put some message there so that it is clear. Okay. And our next step should be we should identify more people who can help us with finding the actual data sources for the columns or the time frame where we have done the prediction. So once we get the actual data, then we will compare it against our prediction to increase our confidence. And then we'll have to replace this also with the actual values whenever we get there.
Oh, okay, sir.
Yeah, carry on.
Then with the predicted calculation, we have started calculating GSDP per capita for uh, the year 2004 to 14. Adjusting the column names here since there is a slight mismatch between the state names from the GSDP data and the population data, like Andaman and Nicobar. Here this is ampersand, and in population data it is A and D, and so we have to take care of that have to since we need the columns with same values to run correctly.
Krishi, just to mention about the issue with the names that you mentioned, right? That is one of the reasons that we'll be working actively on the LGD so that any data set that we take, no, the first activity should be to map the geographies to the LGD. Because once that is done and we update the data set with the proper LGD code, right, it will become easier for anybody to take the data set and then integrate it with any data set where they are already mapped to LGD. So think of it as LGD becomes that common standard for us. Okay,
Oh,
so that we will cover it in another video, but I just wanted to highlight it here. In this video, let's concentrate on the whatever we did with respect to population, GDP, and GSDP, and close the video. Okay.
okay.
Yeah.
Yeah, here we are handling all the missing values by finding a mean for the rows for each row. Then reading the population data that we have calculated earlier in the file. Here we are finding and replacing the column state names that are not matching with each other. These are the state names not that were not matching. Here we are replacing the state names manually for those states. Then swapping the order of the states. In one of the data frames, it was Uttar Pradesh was first and Uttarakhand was second, and in another data frame, it was Uttarakhand first and Uttar Pradesh second. So without having it in the right order, we cannot continue calculation. So I did swap the values in one of the rows so that both the data frames match each other.
Okay. Krishi, there should be some way of joining the two data frames based on a particular key. Just check out pandas and data frames once to figure that out, because we cannot always depend upon the order being the same. Wherever possible, we should look at joining based on the keys itself. So just take a look at it once. And once you figure that out, LGD column will become that column for us to join in the future. Okay.
Okay, okay.
Yeah.
Then we are calculating the GSDP per capita by dividing GSDP by the population for each state and adding it into a new data frame. GSDP by population into a new data frame here. Mm, uh, Here we are adding it into a new data frame without the state name initially. Now we are adding the state names at the first position for our reference. And then, like we used to do, we have segregated the states into 5 different zones: east, west, north, south, and northeast. And then plotted it in with the help of matplotlib library here for east and then west and north, south states and northeastern states finally here.
Let's look at the northeastern. Last time we looked at Assam, no? Okay. So interestingly, Assam, okay, is less itself if you consider the per capita. Arunachal Pradesh is doing better and Mizoram is doing better. Third seems to be Meghalaya in general, right? Okay, that's interesting. And Krishi, we did here only till 2014, is it?
Yes, sir. For 2015 to 23, it was done with a separate file as we
Ah,
have
okay, okay, fine.
the predicted
So
pop.
whenever you do these kind of like separate things also, spend some time to see if you can join them because that will be better, okay? Hmm?
Oh, okay, sir.
So for visualization purposes, if you did splitting, that's okay. But generally, the final data set that we clean up and share should be for the full timeline. That will be better. Hmm?
Oh, okay.
Let's look at northeastern Indian states between 15 to 23. Let's look at the latest numbers once. Yeah, this is very similar. No, you can scroll to the bottom pretty much.
No.
Let's look at the map directly.
Here
Okay,
is the
northeast.
northeastern state.
Okay, interesting. Okay, so if you take per capita, it is very similar, right? Assam, Mizoram, and Meghalaya seem to be that order mostly. And recently, Assam is improving in 2022 compared to Meghalaya. Okay, okay.